Hello, people of YouTube. This is Mr. Branch KHS with some new physics knowledge for you.
Thank you, Rex. All right. So here we have two collision cars. We're going to analyze collisions. Now, yesterday you guys did a little lab where we analyzed collisions. That link is on the Prezi if you want to try it at home.
Oh, we have to take notes?
Yes. It's only a little bit. All right. Now, before we get started on the notes part that Katrina likes so much, let's talk about these collisions real quick. I have it up on the board so you guys can see. We have a blue car and a red car, right? I'm going to have them collide, and I want you to tell me if the collision is elastic or inelastic. Okay? Now, Caleb, yesterday when you guys work in your lab, elastic was when the slider was at 100% elastic. Inelastic was when the slider was at anything less than 100%. Okay? Now, inelastic has a prefix on it. The in means not. So, inelastic is not elastic. Does that make sense, guys? Yeah. So, they're basically opposites. We have elastic and not elastic. So, which collision is elastic? Or is this collision elastic? You guys ready? You guys see up on the board? Crouch down for you there, Jose. Ready? What do you guys think? Elastic or not elastic?
Elastic.
Elastic. Are you sure?
Yes, because they bounce off each other.
Yeah? You are sure?
Yes.
Well,
100% sure.
They're not touching.
Okay.
It's a magnet.
All right. Now, yesterday, when you finished at the lab, you learned, or confirmed some ideas. What do you know about every collision? What does every collision conserve? Momentum. Okay. Does this collision that we just watched conserve momentum? Yes. Okay. Now, what was the difference between elastic and inelastic collisions in your lab?
They stuck together and did not stick together.
Not a little louder? Louder?
Inelastic doesn't conserve energy.
Okay, so inelastic doesn't conserve energy. Right? So, just by examining this collision, can you be absolutely sure it conserves energy?
Yeah, no.
Can you be absolutely sure that this collision conserves energy?
No.
Not 100% sure. So is this elastic or inelastic? You keep saying elastic. Why do you say elastic?
Because they bounce off.
Because they bounce off. Thank you, Skylar. Common misconception. If the objects bounce off, that does not make it elastic. You did write it down yesterday, didn't you? Okay. If the objects bounce off, that does not make it elastic.
No, I said if they stick together.
What makes it elastic?
Conservation of energy.
Louder, Katrina.
Conservation of energy.
Conservation of energy. So if we're conserving energy, that makes the collision elastic. So when I ask you, is this elastic or inelastic? What are you guys saying?
I don't know.
You don't know. Thank you. Because we don't know if this collision conserves energy or not. The fact that they bounce off, guys, does not mean it's elastic. The conservation of energy is what means it's elastic. All right? So there was that one question where I said, what collision can you be absolutely sure if it's elastic or inelastic? Inelastic. And here you go. You guys ready? Is this collision elastic or inelastic?
Inelastic. Whoa.
Inelastic. How do you know, Fong? What's the energy right now?
0.
0. Amani, Jose, why are we talking?
Because we're making sure we turn in our work.
All right. What's the energy right now?
0.
0. Before they hit, what was the energy? Not 0. Okay? Even though these two cars, we know the momentum before was 0 because momentum after was 0, right? But momentum has direction, doesn't it? Does energy have direction? No. So even though these two cars are traveling in opposite directions, their energies are still both positive. Okay? Their energies are still both positive. So when they hit, all the energy is now gone. It's lost. Okay? So since the energy is lost, is energy conserved? No. So if energy is not conserved, that makes the collision inelastic. Does that make sense, guys? So do we have an understanding about those two definitions now?
Yes.
What does elastic mean?
Bouncy.
Elastic means the collision conserves energy, and inelastic means the collision doesn't conserve energy. Good. So, Elastic. Oh, almost forgot my asterisks. So, Unit 7, this is from section 11.2 in your book. It's inelastic versus elastic collisions. Now, these are two types of collisions, but we know every collision conserves momentum. So, all collisions conserve momentum. Okay. All collisions conserve momentum. Every collision, elastic and inelastic, both conserve momentum. Okay, as long as it's a closed system, which is what these are. So all collisions conserve momentum. That means momentum initial equals momentum final, right?
Yes.
Correct? Okay. What does an elastic collision conserve? Energy as well. So elastic collisions conserve momentum and energy. Okay. Elastic collisions conserve momentum and energy. That's fine. Okay. Now, what type of energy do the cars have? Potential or kinetic? Kinetic. So the equation we have is KE initial equals KE final. Right? And remember, KE equals 1/2 mv squared, right? Does energy have direction? No. So now I can simplify this out a little more, or sorry, not simplify, expand this a little more. 1/2 m1 v1 squared initial plus 1/2 m2 v2 squared initial equals 1/2 m1 v1 squared final plus 1/2 m2 v2 final squared.
You want us to write that down?
You can if you want to.
What?
So that's the conservation of energy expanded. Now I only have 2 cars here, so that's why I have 1 and 2. If I have 3 cars, I need 3 kinetic energies. 4 cars, I need 4, and so on. Does that make sense? So in order for a collision to be elastic, it must satisfy that condition. The energies have to be equal. Right? Does that make sense, guys? That makes sense.
Hi, Michael.
Hi, Michael. Any questions?
Why can't you say hi to Trina?
All right. Inelastic collisions. What do you know about inelastic collisions?
They energy equals 0.
Nope, not energy equals 0. Do they conserve momentum?
Yes.
Yes. So inelastic collisions conserve momentum only. Right? Or you could say they only conserve momentum. I like that better. They only conserve momentum. Sorry. Which means energy is not conserved. Which means KE initial, does it equal KE final? No. So KE initial does not equal KE final. So they'll have different joules. Any water with ice is good.
Toilet water?
It's got ice and it's clean, it's fine.
Whoa, well water.
Give me a chlorine tab and I'll make it good.
You want to drink chlorine?
Ew, I hate well.
Chlorine's in there. Chlorine kills all the bacteria. Any questions?
Have you ever smelled chlorine?
What'd you say?
Have you ever smelled chlorine? Why?
Never what? what?
Not intentionally.
All right.
My friend-
Inelastic versus elastic collisions.
Smoke?
Okay.
You just said you were supposed
He
to-
said smell good. All right, guys, I'm still recording. Thank you.
He does not smoke weed.
If you get to here, if you want to go to the surprising page, if you want to get the collision simulator out again, there's the address for it right there. All right. So, to talk about elastic versus inelastic collisions, I want to look at some of our previous examples, and then reclassify those examples as either elastic or inelastic.
That's not either.
So, here's slide around. Example 22 says, look back at example 11 and classify this as either elastic or inelastic. Okay? Now, I'm guessing a lot of us don't have our stuff from example 11 written down, or we forgot those notes today. Am I right?
Yes.
Okay. So, example 11 says a 0.5 kilogram collision car is traveling 1.3 meters per second west, so it collides with a 1 kilogram collision car traveling 0.9 meters per second east. After the collision, the 0.5 kilogram collision car has a velocity of 0.3 meters per second east. What is the velocity of the other car? I remember this correctly, it's called east positive. It's called east positive. M1 is 5 kilograms. V1 initial was 1.3 meters per second. That's positive. V1 final was 0.3 meters per second negative. M2 was 0.5 kilograms. I'm going to do it backwards. No, I did it right. It's 0.5, not 5.
Wow.
M2 is 1 kilogram. My fault. V initial was 0.9 meters per second. No, 1.3. Sorry,
Oh
1.3.
my goodness.
Wait.
The other one was 1.3.
Yeah, and this is negative. Thank you. And this is positive at the end.
I don't have lotion.
And this is 1 kilogram. It's traveling 0.5 or 0.3 meters per second east to start. And the final velocity was 0.9 meters per second west.
What?
Now I know that because I remember doing example 11. And then wrote
Wait,
the
I thought you
information
said
down
it
over here.
was 1.3.
What?
It's 1.3.
Right. 0.5 to start was 1.3. Right? V final is 0.3.
So what are we supposed to do?
Right? We need to classify this as elastic or inelastic, right? So here is car 1 and here is car 2. Right? So if I'm going to classify as elastic versus inelastic, I need to see if what's equal. Energy. So we need to look at KE initial and KE final. Right? Right?
Yeah.
So we have to do 1/2 mv initial squared for 1 plus 1/2 m2 v initial squared equals 1/2 m1 v final squared plus 1/2 m2 v final squared. And now if these two are equal, that means energy is conserved and the collision is elastic. If they are not equal, that means energy was not conserved and the collision is inelastic. Right? So then we can plug in what we know. So 1/2 times 0.5
Where's my calculator?
times 1.3 squared plus 1/2
Reggie, this is not my calculator.
times 1.
25. So you get 25.
Oh, sorry, this was negative 1.3. Okay.
You're pretty smart.
Plus 0.5 squared. Or 0.3 squared, not 0.5. The massive.
How you know that?
Equals 1/2 times 0.5. Done. Pay attention, please. Plus 1/2 times 1 times negative 0.9 squared. Right? So now I've plugged in everything, right?
Yes.
Okay. So can we calculate the left and the right side?
Yes.
You guys do that? Now, one thing to worry about.
I have a question.
Energy does not have directions, right? So do I really need these negative signs? No, because those negative signs are just going to screw you up when you plug it all in your calculator because you're probably not going to put it in parentheses. Right? So, that's 0.3. So I should erase these negative signs because we're not worried about velocity when we're doing energy.
Is this the last new thing we're going to learn?
We're not worried about direction when we have energy.
This is the early one.
basically learning about speed.
Just speed. Yep. It's actually the square of the speed. Okay. Sorry guys, it's 0.3 right there.
Yeah, that's what he just said.
Did you? I'm
Yeah.
sorry. I wasn't listening.
You never listen. We the laugher, whatever.
Yep.
What is the
East was positive. So in the problem we called East positive.
She has her theory. She has her theory.
So what's the left side?
It's 0.4675.
0.4675. What's the right side?
0.4275.
So, does energy initial equal energy final?
No.
These are not equal. So since our initial energy does not equal our final energy, this collision is
Inelastic.
inelastic. Good.
Whoa.
You're like a better person now.
Good. Does that seem easy enough?
Yep.
No?
Except you have to solve the
Okay. Example 23. Classify example 13 as elastic or inelastic. Okay. Now the information for example 13 is over there. I made a list again. The initial velocity of the blue car was 3.95. Alright, so classify example 13. Got that ready. A 0.5 kilogram right collision car is traveling at 2.5 meters per second east and collides with a 1 kilogram blue collision car traveling west. If the two cars stick together and travel together at 1.8 west, what's the initial velocity of the 1 kilogram blue car? Now you guys already did this, right?
We should know the velocity of the blue.
If I gave you this problem out of the blue, blue car. If I gave you this problem out of the blue, so you hadn't calculated velocities yet. Your first step would be to find the initial velocity of the blue car. Then once you've done that, then you can classify. But in the interest of time, we've already did this. We already did this in example 13. So the initial velocity of the blue car was 3.9 meters per second in the positive direction, which is east. Okay. So the initial velocity of the blue car was 3.9 meters per second east. Or west. West, sorry. In the negative direction.
Thank you.
Yeah.
We really don't gotta worry about that.
Alright.
We don't have to worry about the negative though.
You don't need to worry about the negative, no. Because we're looking for energies. But if we're looking for momentums, you would need the negatives. Okay? Guys, then you write that down for you?
I wrote it down already.
So here's the initial velocity of the blue car, negative 3.9 meters per second. That's what you had to calculate. So classify. Take a moment. Shouldn't take us that long. Can I have that hand sanitizer since you guys can't control yourselves? Thank you.
We're getting treated like second graders.
You got it.
Well, it happens.
You gotta do what you did for example.
We did.
Got it.
Thanks for not.
Just one.
Shh.
One.
Which one?
Is it 1 kg or 11?
1 kilogram.
Your K kind of looks like another.
Oh, I'm sorry. About another minute. So what do you think?
Not yet.
Not yet?
More second.
I don't know my one song. I'm sorry.
What's so funny about it?
Nothing.
Like smiling at you. Mr. Smith emailed you something.
No. Yeah. Could have retweeted that selfie already. He's happy.
Someone retweeted it.
So did Kyle.
What's the
Alright, so what do you think? Elastic or inelastic?
Physics.
Who says elastic? Nobody. Who says inelastic? 7 of you. Nice shot. Alright. So, what was the initial energy?
It was 9.3675.
Was it? So initial energy was 9.3675?
36375.
Okay, and you got that by doing 1/2 of 0.5 times 2.5 squared plus 1/2 of 1 times 3.95 squared?
Yep.
Okay. And then the final energy was 1/2 times 1.5 times 1.8 squared. And it was what? 2.43. Okay. So this is inelastic because the energies aren't equal, right? You can also think of this. The cars stick together. Right? So instead of doing all that work, you could have said, hey, the cars stick together. It's inelastic. Okay. Because inelastic collisions are where things stick together.
Yeah.
Does that make sense? So if they stick together, you know right away it's inelastic.
Right away.
Alright? And it does not conserve energy. Any questions?
Are we done?
Any questions?
Because